So last page of lesson 2, we have 4 graphs. The equation of the graphs are given. Have we done A and B?
Yeah.
No.
No.
Chris.
Oh, we did. Chris.
You were going to, but then class had like.
We didn't have enough time.
Christian on his own.
Okay, so if you take a look, we have the equation of the original function in this case, y is equal to the absolute value of x. And then we have the transformed image, which is in bold. We have to figure out what would the new equation be after the transformation. So any guesses how we're going to figure that out? Going from thin to thick. How do we move that graph? What's the translation?
X minus 2.
Whoa, 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 one at a time. Emily.
Like you just, where you see where the point goes, so it goes like, move right to.
Okay, did you pick the vertex?
No, I picked the top corner,
Which one?
like the top left.
Top left? Okay, so basically you can pick any point you want on the graph and then you just move it. For me personally, I would pick the vertex because it's the most obvious critical point. Whereas if you picked a point up here and then tried to compare it to say this graph, if my arrow is a bit longer, it might be hard to determine that. Okay, so probably for the point you used it would still work because they're the same size. But I would recommend use an obvious point. So vertex, we're at 0, 0, and the new vertex is at, where are we at? 1, 2, and 4 down. So 2, negative 4. So how many spaces have we shifted to the right?
2.
So right 2 and 4 down. Or down 4.
Yeah, less than minus 2. Try to put that in.
So in comparison to our original function, y is the absolute value of x, we have to write that as a new equation. Given the transformations, right 2, down 4. So that will be y equals the absolute value of x minus 2 and then minus 4. Is that what you got, Emily? Good job. Okay, next graph. We have the reciprocal function y equals 1 over x. Okay, just keep in mind there's 2 pieces to this graph. Okay, here and here. We have a vertical asymptote in between. Okay, let's just mark out a key point on that graph, maybe here. And we're going to figure out where it ended up. Okay, so we're going to go up 2 and to the right 1. So up 2, right 1. So our new equation will be y equals 1 over, if we're going to the right, we have x minus 1, and then we got to go up 2. So y equals 1 over x minus 1, all plus 2. So this is pretty straightforward, we're just counting spaces. Not bad? Okay, C and D, they don't give us the actual equation, but we still have to figure out how it's transformed, and we're going to put our answer in function notation, not into an actual equation. Okay, so again, the original graph is in the thin line, and we've got to figure out how did it transform to the thick line. So take a look, how many spaces has it moved left or right, up or down? Done? 4 down? Okay, so if we took this critical point here and we moved down 1, 2, 3, 4, you have the top of the mountain on the thick graph. Good. Same thing if you took this point and you moved it down 1, 2, 3, 4, same thing. It's consistent. Okay, so we're moving down 4 spaces, which means that our new function, y equals f of x, will be transformed to, will be f of x minus 4. So y equals f of x minus 4. Okay, Bruce, how about the next one?
F of x minus 3 minus 4.
Okay, so he thinks it's f of x minus 3 minus 4. So let's just see, going from here to here, Okay, we've gone 1, 2, 3, 4, up. So is it still -4?
I thought we were going,
What was the
You
original,
can-
thin or thick?
confuse the thin
Yeah.
and thick.
Okay,
That's
good.
it,
So
right.
let's start over.
okay,
The
X
thin one is
plus
the original,
3 plus 4.
and then the thick one's the new one
Oh, yeah.
after the
FX
transformation.
play. Opposite sides.
Okay, so we're gonna go up 4, and we're gonna move to the left 1, 2, 3. So we have to just change the signs. Good.
No, that's fine.
You got it.
No, that's-
I know you know what you're doing. Okay, how are we doing so far? Is that alright? Okay, next one. You gotta use your heads a little bit. So we're starting with the original function. We have y is equal to the square root of x. What vertical translation would be applied to our original function so that the translation image passes through points 16, 7? Well, what we do is we have to realize that with transformations, what we've learned so far is we have this equation. Y minus k equals f of x minus h. K implies that we have a transformation or translation related to y, so a vertical translation. H shows us that we have a horizontal translation. They're asking us to figure out what vertical translation would occur if the original graph is translated and then goes through this point. So if we have a vertical translation, are we talking about K or H? Okay, so we're talking about K. So our goal in this is to solve for K. Okay, that's what we need to solve in the end. How are we going to do this is first write out that we have y minus k is equal to the square root of x. If there's a vertical translation, that means the original y is going to be replaced with y minus k. Something's happening to y. Okay, so step 1 is show that there's a vertical translation. Okay, step 2, sub in the point xy. Okay, and that point was 16, 7. So if we sub 16, 7 into our equation, okay, y is 7, k is unknown, and we are left with the square root of 16. So 7 minus k equals the square root of 16. We've subbed in our x and y. Last thing to do, what's our goal? Solve for k. So step 3, solve for k. So we just have to rearrange. We get 7 minus the square root of 16, or 7 minus 4, equals k. K equals 3. What did we say if k is a positive number? Up or down? Up.
Up.
If the value of k is positive, we move up. So let's just sub that in. We had y minus 3 that we're subbing in. That equals the square root of x. If you rearrange it for y equals, what happens to that negative 3? We add it. So we're going up 3. Okay, k is positive, we go up 3 units. And we're happy with that. Brett's happy with it.
Oh, yeah, it took me a while.
Okay, lots of chit chat. So, do we have questions on any of the steps? Stan,
No, we're good.
you're going to do this on Tuesday?
Yeah.
Okay. Part B, we have a horizontal translation. So instead of dealing with K, we're dealing with H. Okay, only X will be affected. Another way to write this is X is going to be replaced with a horizontal translation, X minus H. So the goal of this is solve for H. So step 1, we've got to show that our X will be replaced with an X minus H. There's going to be a horizontal translation. So y will equal the square root of x minus h. Okay, step 2. Sub in our x and y coordinate, which happens to be 17, 8. So the x is 17, the y is 8. Lastly, step 3, well I guess we gotta sub it in first, so we have 8 equals the square root of 17 minus h. So then the last step, step 3, is to solve for h. Okay, I'm hearing the right answer already, so good job. Okay, first of all, to get rid of the square root, we're going to square both sides. So 8 squared is 64. Squaring a square root gets rid of that square root, so we have 17 minus h on that side. We subtract 17 over, we get 47. That equals negative h. So to get h completely isolated, divide by negative 1. And h is equal to negative 47. H is negative. We're talking about horizontal translations. H is negative, so are we moving right or left?
Right.
Who votes left? Who votes right? Dawson, good job.
Well done.
I'm glad you didn't change your mind. Okay, we're moving left. 47 units.
Wait, who? Can you also go plus h to the other side? And then
Yes.
minus
Yeah.
this?
You still got negative 47, right?
Yeah.
Yeah, good. Okay, let's talk about this. The whole class voted the opposite way, so obviously we need to talk about this. Okay, we had y equals the square root of x minus, and what are we subbing in for h? Negative 47. So what's it going to do to the sign? It's going to become a positive 47. X plus 47. If you saw this, which way? Who votes left? Well, I already gave you the answer, so glad your hands are up. Okay, left. 47 units.